Welcome to another episode of Mastering Cybersecurity, developed by baremetalcyber.com. Let's dive in. Cloud services come in layers that define how much you manage and how much the provider handles day to day. Infrastructure as a Service, IaaS, offers virtual machines, networks, and storage that feel like familiar building blocks you configure yourself. Platform as a Service, PaaS, provides a ready environment to run code without managing servers, which can reduce busy work and speed delivery. Software as a Service, SaaS, delivers complete applications you simply use, like email or document sharing, with almost no infrastructure decisions required. A housing analogy helps. IaaS is like buying a condo shell you still finish. PaaS is like a service department with utilities handled, and SaaS is like checking into a hotel room ready for immediate use. Knowing who manages what at each layer clarifies effort, control, and risk. There are several common ways to deploy cloud solutions, and each matches different needs and constraints. Public cloud is a strong default for new projects that value speed, elasticity, and broad service choice with predictable operational effort. Private cloud fits when strict isolation, special hardware, or particular regulatory models require dedicated environments with cloud-like automation. Hybrid cloud keeps some systems on-premises while moving others to the provider, which is useful for data gravity, latency needs, or gradual migrations that respect existing investments. Multi-cloud intentionally spreads workloads across providers to reduce concentration risk, reach unique services, or meet regional controls. But it adds design and skill complexity that must be justified. Beginners do well by picking one clear primary path and adding complexity only when a tangible driver exists. Security and operations in the cloud work under a simple, powerful idea known as the shared responsibility model. The provider secures the underlying facilities, hardware, and core services they run, including physical access, power, and foundational networking with strong controls. Customers remain responsible for the configuration of their resources, their data, their user access, and their application behavior, even when using higher-level services. The exact split changes by layer, with IaaS placing more on the customer and SaaS placing more on the provider, while PaaS sits in the middle, requiring careful attention. A helpful habit is to ask, for every risk, whether it lives in the provider's domain or in your configuration choices. That question keeps designs honest and makes incident reviews faster and clearer. Efficiency gains in the cloud come from four simple levers that reinforce each other when used deliberately. Elasticity means resources can grow or shrink quickly, while scalability means the system design supports that growth without breaking performance or reliability. Pay-as-you-go pricing maps cost to real usage, which reduces waste from idle capacity and helps teams experiment without large upfront purchases. Global reach places services near users across regions so applications feel faster and data can stay where regulations require. Auto-scaling ties these ideas together by adjusting compute counts to live demand, which keeps response time steady during traffic spikes and reduces spend at quiet times. When teams measure usage and set sensible limits, these levers turn speed into savings rather than surprise bills. Cloud architecture uses a small toolkit that beginners can learn and apply with confidence over time. Compute often starts with a virtual machine, VM, that behaves like a familiar server, great for legacy software or stable long-running tasks. Containers package applications with their dependencies for consistent moves between environments, helping teams deploy small services quickly and predictably. Serverless computing runs functions or jobs only when triggered, removing server management and matching cost directly to events or requests. Storage choices follow data behavior. Object storage handles large files and backups cheaply. Block storage powers databases and operating systems, and file storage supports shared folders across virtual machines. Basic networking connects these parts with private address spaces, subnets, routing, and gateways that keep internal traffic safe and predictable. Identity underpins almost every cloud decision, so getting access right keeps projects safe and productive from the first day. Identity and Access Management, IAM, organizes people, services, and machines into accounts that can assume roles, which collect permissions for specific tasks. Policies describe what actions are allowed on which resources, and least privilege means granting only what is needed for the job at hand. Multi-factor authentication, MFA, strengthens logins by combining something you know with something you have or are, reducing account takeover risk. Single sign-on, SSO, connects central identities to cloud accounts so departures, role changes, and audits remain consistent across teams. Clear naming, role templates, and periodic reviews keep IAM understandable as projects grow and responsibilities shift. Reliability in the cloud comes from designing for failure, not hoping it never happens in a busy world. Regions and availability zones provide geographic and infrastructure separation so a fault in one zone does not stop services in another, which reduces correlated outages. Redundancy patterns place multiple instances behind health checks, so traffic flows to healthy copies when problems appear unexpectedly. Backups capture data consistently, while disaster recovery plans define recovery time objective, RTO, and recovery point objective so teams know acceptable downtime and data loss. A small failover scenario could shift a database replica across zones when health checks detect trouble, keeping applications responsive while repairs proceed methodically. Measured practice through drills turns plans into habits that hold up during stressful incidents requiring coordinated responses. Cloud costs are manageable when teams connect pricing models to steady habits that prevent drift and waste. On-demand pricing charges per unit of time or use, great for unpredictable workloads, while reserved pricing trades commitment for meaningful discounts on stable baselines. Spot pricing buys spare capacity cheaply but with interruption risk, which suits batch jobs that can pause gracefully without any loss of important state. Tagging resources with project and owner information enables budgets, dashboards, and alerts that surface idle assets before they compound into large monthly bills. Right-sizing trims oversized virtual machines and storage tiers by matching actual usage to suitable options with simple measurements and periodic reviews. Small pitfalls like forgotten test environments, unbounded logs, and unused snapshots often add up, so regular housekeeping protects both clarity and cache. Security in the cloud builds on a few fundamentals that align with modern, practical safeguards suitable for teams of any size. Encryption in transit protects data moving between services, and encryption at rest protects stored data, both enabled with sensible defaults that deserve verification during setup. Key management uses a provider's key management service, KMS, or an external option to generate, store, and rotate keys with clear ownership and access limits. Logging and monitoring record resource changes and access events, which helps detect misconfigurations and build timelines during investigations that need detailed evidence. Zero trust principles assume networks are not automatically safe, so every request should be authenticated, authorized, and limited based on clear context. When combined with IAM discipline, these basics block common mistakes and make advanced controls easier to add later. Getting started can be simple by picking a tiny project that teaches the pieces working together without overwhelming details. A small static website can live in object storage with a content delivery layer, while a minimal serverless function handles a contact form and writes into a managed database. That design uses storage, networking, access policies, logs, and automated deployments, which covers many fundamentals in a compact and friendly way. A plain architecture diagram that names each building block helps teammates see how requests flow and where security checks happen. Avoid the lift and shift trap where old servers are copied into the cloud without rethinking cost, reliability, and automation, because that keeps legacy pain while adding new bills. A small modern design builds confidence and creates patterns that scale safely and predictably. As comfort grows, the same fundamentals guide choices when projects expand across teams, regions, and services. Earlier IaaS deployments can adopt managed databases, queues, and caches that reduce maintenance toil while improving predictable performance for users across many devices. PaaS options absorb routine patching and scaling, letting small groups focus on application code and security decisions that map to business outcomes. SaaS tools can fill gaps like analytics, logs, and testing, provided access is integrated with IAM and data handling is documented clearly. Patterns like blue-green deployment and feature flags reduce risk during updates by separating release from activation, which encourages smaller, safer changes. When teams review metrics, error budgets, and cost trends together, they learn which adjustments matter most for reliability and efficiency. Day 2 operations in the cloud benefit from habits that keep environments understandable, traceable, and ready for change without surprises. Clear tagging and consistent naming ensure teams know who owns each resource, why it exists, and what can be retired safely with confidence. Change records that link to tickets and approvals create a timeline that shortens investigations and clarifies who did what, where, and when. Alerts based on meaningful signals, not noise, help engineers focus on real issues instead of chasing false positives that waste time and reduce trust. Regular reviews of security findings, unused permissions, and long-lived credentials close gaps that grow quietly when no one is looking directly at them. Small runbooks that explain rollback steps keep deployments calm because the path back is known before problems appear. Networking in the cloud mirrors familiar on-premises designs while adding managed features that reduce heavy lifting and undifferentiated setup. Private networks with subnets isolate workloads, while routing tables and gateways connect them to the internet or other networks as policies allow carefully. Network access controls filter traffic by source, destination, and port, which limits blast radius when a service is exposed more than intended by configuration changes. Load balancers distribute requests across healthy instances, improving reliability and giving breathing room during maintenance, updates, or unpredictable traffic bursts. Private endpoints connect managed services without traversing public paths, which reduces exposure and simplifies compliance reviews that examine data flows carefully. These pieces create a simple pattern: isolate by default, expose with intent, and measure traffic so surprises are rare and quickly understood. Observability turns running systems into understandable stories by collecting signals that tell what is happening and why it matters to users. Metrics measure rates, durations, and resource usage so teams can see trends and plan capacity before problems grow into outages. Logs capture detailed events that explain decisions and errors, which support both debugging and security investigations that require precise timelines and responsible actions. Traces connect requests across services, so slow paths and bottlenecks are visible, which guides improvements that users actually feel across their daily journeys. Dashboards and alerts convert these signals into fast feedback loops that keep teams focused on service quality rather than opinion or guesswork. When observability data informs capacity, cost, and security reviews, cloud environments become easier to steer with steady hands. Finishing the fundamentals, teams can think about growth, governance, and teaching these ideas to newcomers who will own tomorrow's improvements. Access patterns should remain simple and well-documented so people can join and contribute without private maps or hidden rules that slow progress. Budgets, error budgets, and service objectives give a shared language for trade-offs, which keeps decisions clear when time or money is tight for many months. Security programs gain strength by automating checks for known risks, while still reviewing unusual changes with human judgment that fits context and impact. Architecture discussions can reference common patterns instead of one-off builds, which reduces surprises and makes reliability more repeatable across many teams. The same small set of ideas continues to compound: shared responsibility, identity discipline, measured reliability, and cost awareness working together. In closing, cloud computing improves speed and efficiency because capacity is flexible, services are ready to use, and costs are tied to real demand. Clear vocabulary makes teamwork smoother, while layered service models explain who manages what, which reduces confusion and avoids gaps that later become incidents. Identity discipline guards access, redundancy protects availability, and encryption plus logging safeguard data while making investigations faster and more grounded. Simple architectures that match needs, plus regular reviews of cost and configuration, keep environments lean and understandable. These fundamentals help beginners describe the cloud, select practical options, and move forward deliberately with fewer surprises and stronger results. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.